Very good morning and welcome to your science lesson. Today, Wednesday the 20th of January 2021. And today we are going to be thinking about what do plants need to grow well. Okay, so in your science books, write today's date, the title and your Wilf. Remember to use neat writing, underline and make it look awesome. Okay, so get that done, and when you're done, we can crack on with today's work. So, our learning powers. We're going to be doing quite a lot of planning in this lesson, and you're going to be needing to do either print off a sheet, or you can copy it directly into your book, so do not worry, and I will talk you through that when we get to the right page. We're going to need to do lots of questioning in today's lesson. We need to be making predictions about what we think is going to happen in our investigation. And we're going to need perseverance, because actually we need quite a lot of patience with the investigating we're doing over the next few weeks, because it's all about watching seeds grow. And although it does happen overnight, because plants are always growing, equally, it's a bit of a long process. So we're going to need perseverance and patience to get through these next few lessons. Okay, now, here are the Wilfs for today. Bronze, you can make simple observations about what plants need to grow. Silver, explain using examples what plants need to grow. Gold, to give detailed account about how different factors affect the way a plant is able to grow, so you need to be able to explain it in more detail. And for challenge, write an explanation about an investigation explaining the best environment a plant can grow in. And these Wilfs are probably going to stick with us now for the next few weeks, because it's kind of the journey that we're on with our investigating. Okay, let's do a bit of a memory quiz. Let's do some retrieval of information that we've learnt before. Thinking about our curves, key instant recall facts. So, a good number of weeks ago, we were looking at food and the importance of the food we have, and the food groups and what food goes into what food group. So here's a question. What sort of foods provide us with vitamins and minerals? Start thinking about that one. 7 weeks ago, we were thinking about the skeleton. So what are the 3 main jobs of the skeleton? Can you remember that one? And 4 weeks ago, what we were doing about light. Who can remember the colours of the rainbow? Although that's kind of almost a general knowledge question. There are 7, I'll give you a clue. So have a little go at thinking about those things. Pause here if you want to. If you want to make a note just underneath your date and title, and make a note of what you think the answers are, you may. But here are the answers. So, the types of foods that provide vitamins and minerals: fruit, vegetables, meat and fish, and there's lots more besides, but essentially those main food groups are the ones that will provide you with lots of good vitamins and minerals. The 3 main jobs of the skeleton, can you remember that one? Support, to protect, and to move. Okay, so we said last week about the brain is protected by the skull, and our lungs protect our heart. Sorry, our ribs protect our heart and our lungs, not our lungs. So the ribs protect that. And the colours of the rainbow. I always learnt this one as Richard of York gained battle in vain, because ROYGBIV show the colours of the rainbow. Red, Richard. Orange, of. Yellow, York. Green, gained. Blue, battle. I, indigo. In. V, vain, violet. So there you go. Richard of York gained battle in vain. That's how I always remember it. That might help you. It might not. But there's our colours of the rainbow from before when we did our light topic. Okie dokie. So, having a look at these are the main science objectives for year 3 and our current topic. And the reason I put this in is because this is the key things that we want you to learn and why we teach this unit. And I wanted to pick up on this bit here today, working scientifically, because it's so important we remember our working scientifically methods. And we've got 4 or 5, I think. We've got pictures of them on our science working wall in school. But this is all about careful observation, okay? being able to take accurate measurements, that's going to come in a couple of weeks, because we'll be measuring the plants that we've grown. Certainly, and if you haven't, I've got my plants that I'm growing for you. Okay, so that's what we're going to be working on, and I just think careful observations is the key thing. Don't focus too much on here, okay, because that kind of gives all the answers away for what we're going to investigate, so I'll move on. Now, last week I asked you about geotropism. What is it all about? And I planted 3 bean seeds, and I planted them in different directions. If you remember, I had one facing the right way, one facing sideways, and one upside down. And if you look, you can see just about the roots have started to come out of each of them. Now, the root that has shot out the quickest is here in seed 2, and this is the one that was sat sideways. Here's seed 1, which is facing the right way, that a seed, the point of geotropism, and as you're going to see in a video in a moment, the real key about this is, guess what? Doesn't matter which way up you plant the seed. This is how clever they are. This seed is officially, or technically, upside down. But if we look carefully here, you can see the root has started to come out, and it is starting to already grow down, just like the way this root has come out. Now, funnily enough, this seed, seed 1, has come out, but it's not grown as much as the other 2. Given that that's technically the right way up that the seed should be, it's actually been the slowest growing seed so far. But I'll give you an update picture of this in the next lesson, just for you to see how it's coming on. Because even since I took this picture yesterday, the seed, that they've been growing really, really well. So I'll show you an update on that next week. But what we're going to do, because we can't wait forever, I wanted you to understand what geotropism is, because it's a really key part of our science learning for seeds. So we're going to watch a video. It says click the picture, but I have already, wrong one, got it open. We're going to watch this and have a little listen to what this lady did with a very similar idea of using big beans like I did. Have a watch of this.
My massive beaker and some relatively tiny broad beans to show you how geotropism works. So if we look at our broad beans close up, you can see they have this end on them, and this is the end where things are going to start happening. But what I want to show you is, does it matter whether this end is pointing down, or does it matter whether it's pointing up, or does it matter whether it's pointing sideways? So here they are, with a little nodule on the left, with it on the right, with it on the bottom, and with it on the top. I'll water these and track these over a few days and show you in which direction the shoots and the roots grow. 3 days in, and we can see one of the little beans is producing a little root. So this one we have something coming down, here we have something emerging, and this one, something is emerging at the top. It is July, so very warm and sunny, and very quickly all of these have produced shoots, roots that are going downwards, and here we have a shoot that is going up. You can see root development is coming along really well now, with all 4 pointing roots down below. This one here, the shoot hasn't started up yet. This one's kind of thinking about it, and the other 2 have shoots going upwards. So here are our broad beans after about 2 weeks. And you can see in all of them, the roots are growing downwards and the shoots are growing upwards. So this is an example of geotropism, because all of the roots are going downwards towards gravity and all of the shoots are growing upwards away from gravity. So here are our plants, and just to recap, this one here had the little nodule at the top, this one had the little nodule at the bottom, this one had the little nodule on the right, and this one had the little nodule on the left. But it doesn't matter where that little nodule is, it doesn't matter which way up, round or down the seed is. All that matters is the effect that gravity has on the way that the seeds are growing. So we can see all of these roots downwards and all of the shoots growing upwards. If we can take...
And we'll pause it there. Okay, so that's just a really handy video to see a slightly quicker process of what I've been trying to achieve here, but it's the exact same bean, broad bean that she used. She did it the same way, the horizontal, the up, the down. And interestingly, her horizontal seed worked the quickest, didn't it? If you remember from the video. So that's quite interesting, the horizontal way. But actually, the amazing, wonderful thing, and I just think the amazing aspect about the world we live in, is that these seeds do not need to know whether they're upside down or not, because they just work it out. Does that mean they've got a little brain inside them? No. But they are made in such an incredible way. Seeds have developed themselves in such a way that they know they can respond to gravity, and they know for their roots to go down in response to gravity, and they know that means their shoot, the plant part of the seed itself, will go up. So absolutely phenomenal. Incredible, I think. I love that. But anyway, right, that's geotropism. Moving on. So this is the main part of today's lesson. What do plants need to grow effectively? And this is what our investigation is going to be looking at. Now, plants are living things. That means there are 7 life processes that tell us if something is alive. The 7 life processes, and these are really important to try and remember, are movement, respiration, growth, reproduction, excretion, nutrition, and sensitivity. Plants do all 7 of these things. Excuse me. So plants do need certain conditions to help them grow well. And you may have already looked after plants, and I know some of you have already got seeds from school, so that's good. So what do you have to provide it with to help it grow? What do you think plants need? Share your ideas with your class, except you can't. So what do you think plants need? Make a little note here, pause the video here and write down in your book, what do you think? Before we do any more learning, what do you already know? What do you already think a plant definitely needs to help it grow? Pause here, have a little write down. Go. Okie dokie. So today we're going to find out exactly what plants need to grow well. Scientists find things out by setting up investigations and gathering results, which is and we've done that ourselves in school last term with our investigation into light and the experiments we did with that. So we know there are different types of investigations: fair tests, comparative tests, exploring and observing, finding patterns, or sorting and classifying. And I wonder which of those you think we're going to need. Now, fair tests is always just in relation to the conditions in which you do any type of test. Are there things that are the same? Are there things that are different? Okay, and in the main aspect that we're going to be looking at is exploring and observing. Okay, so that's the main investigation type that we're using when we're looking into the plants over the next few weeks. So what can we find out? So this will be an exploring and observing investigation, so we can see what happens to plants in different types of conditions. We will investigate the things plants need to grow well. Mr. Davey will get a healthy plant and set up our investigation. Okay, so I have set the investigation up. I planted last week some seeds. And they're in 5 different pots, and I'm going to talk you through it shortly. But first of all, what are we going to investigate? Scientists always start within a question that they want to investigate. We're going to investigate each of these statements below using 5 different potted plants. What happens if a plant has no water? Can a plant grow in the dark? If a plant has no heat, will it still grow? And there's a challenge there. Can you maybe think of your own question to explore? Okay, when you've decided, complete your investigation planner. Right, your investigation planner. That is something that we're going to be drawing into our books, or you can download it from today's lesson channel. So if you do want to print off the sheet, you can, but don't worry, it's simple enough for you to copy into your book. So here we go. This is the sheet here. What do plants need to grow well? That you're going to put into your book. And I've said here, if you've been able to get your own pot and seed from school, then you need to look after it and use the key aspects of what makes a plant grow well. Record your results of how it grows and take pictures. Once the shoot comes up, start measuring the plant on a weekly basis. Record the results in a table format, and I'm going to be giving you that what it looks. I'll be giving you the results to record as well, so don't worry. It will become clear as we work through this activity. So you can download this sheet from Teams. If not, pause the video here and complete the box and put your answers in. Okay, so you got the question. What do you want to find out about? Okay, choose your question. Again, you can go back to here and you can choose from these three here. In fact, you can add these three from here if you want. Then you need to make your prediction. What do you think it will happen to your plant? Now, when it says your plant, you're going to write about the 5 plants that I've grown. Okay, but so what do you think is going to happen to your plant as they grow? And then method, what are you going to do? Okay, so you're going to plant 5 seeds. Well, this is what Mr. Davies done, so you just need to write in what I've done. Mr. Davies planted 5 seeds in different types of conditions, and we will be observing what happens to the seeds. Okay, so that's the method. 5 seeds, 5 pots, different conditions. What are we going to find out? Okay, so pause here if you need to copy this into your book. Obviously, don't worry about writing twinkle. If you want to draw a little plant, you can. But they're not sunflower seeds. I have not planted sunflowers. I've planted peas. We're like 2 peas in a pod, and no, it's not a little odd when we're apart. We're like... I don't know why I'm singing that song. It's a show I did when I was 12 years old. Anyway, moving on. So, now your investigation is set up, you will need to watch your plant carefully. Well, that's certainly an instruction to me, because I'm doing this on your behalf. If you have your own seed, do lots of observing. Each week, make a note on a sheet of paper how it's going. Okay? Now, when scientists look carefully at things, it's called observing or making an observations. That's our scientific talk there. Over the coming days and weeks, you're going to observe your plant regularly and see if you notice anything. If you do observe anything happening or changing, record it on your recording results sheet. You only need to fill that in once a week when we do our science lesson. Now, when you've completed your observations, you will look at your results and think about what you found out. Now, don't worry, I've said here, if you do not have a seed that you're growing at home. I'm doing this for you, all right? So if you have your own seed, there's going to be a sheet that you can fill in for that. If you haven't got a seed, you're going to be doing my sheet. In fact, you're all going to be doing my sheet as well, because that's the main focus. If you have got your own seed, that's just for you to kind of do as a side project, but still keep notes on it. So there's the sheet that we're all going to do, okay, that I've just shown you and that you fill in. That's the first thing that you do today into your book. Now, this sheet... you don't need to worry about, oh yeah, you do need to worry about this one. In that, I don't mean literally worry, in that you can copy this table into your book, or if you want to, it would take up a whole page, or if you want to print it, you can print it. And very shortly, I'm going to be filling in this first column of week 1 observation. So you're going to have 2 things to copy into your book, or 2 things that you can print off. This sheet and this sheet. And you can stick them into your science book, or if you can't print things off, that's not a problem, because you can copy this into your one whole page of your science book, and you need to copy this whole thing into your science book, which I know looks quite a lot, but as long as you've got a pencil and a ruler, you'll be able to do it. So pause here if you need to get that copied into your book. So this is the second thing that you need to copy into your book. So you will have just done this one. Now you've got to do this one, and in a moment, I'm going to be filling in this column. Now, this is just the bonus sheet. If you are growing your own seed, or you've collected one from school, this sheet is your side project sheet, and you can basically fill this in as you like. Okay, so what are your observations after 1 week of having your plant? And then which you could fill in today. If you excuse me, if you've already had your plant for a week, and even if it's not been quite a week, you can still fill this in. What do you notice about what's happened to your plant so far? Then next Wednesday, you'll fill in that one. Wednesday after that, you'll fill in that one. Wednesday after that, you'll do that. And actually, to be honest, it's going to go into half term. So you might just need to make a little note here during half term as well. And then you can just fill in these two boxes at the end of the investigation. But as I say, this sheet is not necessary for everyone. It's only if you have managed to get your own seed growing. Otherwise, stick with the other two that I've already shown you. I know it seems a lot, but you can do it. It'll be fine. Now, today's planning and recording of results will happen over the next few weeks. All you have to do is each Wednesday, because that's our science day, is take a look at your plant and write onto the sheet about what you can see in terms of the growth. We will all fill in the sheet from the previous slide from the plants that I've grown, and there will be a slide in each science lesson that you can pause and copy the results from onto your copy of the sheet or into your book if you've drawn the table into your book. So, ta-da! The results are in. Here are what each of the 5 potted plants look like so far. Very exciting. Here's pot 1. Pot 1, now every single pot, 4 of the pots have just one single seed. The 5th pot has 10 seeds in it. I put loads of seeds in. And so that's the crowded pot. You'll see that one in a minute. It's quite interesting what you're about to see. So we're going to fill the results in a minute, but have a little look at these pictures. These are the real pots that I've planted, and I took these pictures today. This pot, pot 1, has light, water and warmth. And you can see that a single shoot from the single seed that I planted has started to grow. This pot, pot 2, has no light. I'm keeping it in a cupboard, but I am giving it water. So the 3 things, it's got one of them. It's got the water, but it doesn't have the light and it doesn't have the warmth because the cupboard's quite cool. This is sitting in my kitchen, so it gets lots of warmth just because kitchens tend to be quite warm places. Now, pot 3, pot 3, no light, no water. Goodness me, and no warmth, because that's in the cupboard as well. So there's no warmth with that. It's been starved of everything. And can't really see anything growing there. And in fact, no, can't see anything there. Now, pot 4 does have light, and it does have warmth, but it doesn't have water. So these two are sat next to each other. This one's getting everything, and this one's only getting the light. Okay, so there's no water it's getting the light and the warmth, but no water. Okay, so that's plant 4. Can't really see anything there. Now for the 5th pot, and you could be quite surprised by what you're about to see. I can't pretend that I know the answer to this. But, whoa, check it out. They're springing up all over the place. These seem to be, even though it's overcrowded with seeds, it is getting the light, it is getting the water, and it's getting the warmth. So pot 1 and 5 are getting the same things. But this seems to be growing incredibly well. I mean, if you look at the size of that, that's approximately 1.5 centimetres high, because I did measure it. Whereas this seed is probably only about, maybe not even a centimetre. So pot 1 and pot 5 are getting water, light and warmth. But boy, they seem to be growing brilliantly. And I'm surprised by that at this stage, just because there's so many seeds in there. It'll be interesting to see how well they grow after this initial phase. All right. So what we're going to do now is I'm going to write into the recording results. So I'm going to put that on for you now, and you're going to see what to do. So watch this. Ta-da! Here's our sheet that you've either printed or been able to copy into your book. And we're going to fill in week 1 observation, because all we can do is write about week 1. This is what's happened after 1 week of the plants growing. So in pot 1, there was light, water and warmth, and there is a shoot. So I'm just going to put a shoot has grown only a little bit. Now the next one is quite simple. Dark, but with water. So pot 2 is in the dark. No water, with water, but no warmth. Nothing. Nothing has grown. Okay, so you can just write that in. Number 3, pot 3. Dark, no water, and no warmth, and nothing. See, this is quite quick, has grown. Pot 4, there's light, and there's warmth, but there's no water. No water. It has got light and it has got warmth. No water. Nothing has grown. So it's very simple to write at the moment. Nothing has grown. And number 5, this is the overcrowded pot with lots of seeds in one pot, which also has the light, the water, the warmth, just like the first pot. And actually, do you know what? Quite a few shoots have grown. So we can write that. Let's show this so you can see it. Quite a few shoots have started to grow. One shoot is 1.5 centimetres tall. Okay, so that's just our observation. So we don't need to do too much detail. It will be interesting to see what happens for week 2. Okay, do we think there's going to be any change? All right, have a little think. Maybe in your science book, write a couple of predictions. What do you think is going to happen to plant 2? Do you think, even though it's in the dark, it is getting water? Do you reckon maybe that might start to grow? Might it start to manage to put out a shoot and for us to see a bit of growth? Okay, so there you go. That's for you to copy and for you to make a note of. You don't have to write exactly the way I have, but it's just a modelled example. And we will go back to our main screen. So look, 1, 2, 3, 4, 5. 5 shoots so far. Actually, I wonder if that's worth putting on the visualizer here. Quite a few shoots have grown. I think we need to say 5 out of 10 seeds have started to grow. Question is, with it being so crowded, will they grow as well? They started off really well, but it'll be interesting to see come week 5 how good they are. Anyway, right, so there we go. Bit of higher order questioning for you. What do these early results tell you so far? Make a note in your science book about your predictions. And to be honest, that is the end. So, well done for getting through today's lesson. Do not worry if you haven't got any plant. Don't feel you're missing out because you have got what I'm doing, and I will keep you updated with pictures each science lesson, so you can see how it's going. Okay, but for now, well done. Thanks for all your hard work. Keep it up and enjoy watching the plants grow. Take care. See you later. Bye.